In this lesson, we will begin the study of different integration techniques. Now, to begin with, we will review all the integration formulae that we have done so far. Now, what are those integration formulae? The first integration formula is the power rule. Integral u to the power of n du is u to the power of n plus 1 over n plus 1 plus c. The second one is the logarithmic form. Integral 1 over u du is ln of u plus c. Integral e to the power of x dx is e to the power of x plus c, or integral e to the power of u du is e to the power of u plus c, that form. Integral sine u du is negative cos u plus c. Integral cos u du is sine u plus c. Don't confuse these. Integral tan u du is negative ln cos u plus c. Integral cot u du is ln sine u plus c. Integral secant u du is ln secant u plus tan u plus c. Number 9. Integral cosecant u du is negative ln cosecant u plus cot u plus c. Number 10. Integral secant squared u du is tan u plus c. Number 11. Integral secant u tan u du is secant u plus c. Integral cot u cosecant u du is negative cosecant u plus c. Integral cosecant squared u du is negative cot u plus c. And look at these forms, very important forms. Integral 1 over square root a squared minus u squared du is arc sine u over a plus c. Look at that form, the denominator, square root a squared minus u squared, an important form. Next one, integral 1 over absolute value of u, square root u squared minus a squared du is 1 over a arc secant u over a plus c. Now again, don't confuse between these two forms. In here, the denominator is square root a squared minus u squared. That is an arc sine form. The denominator here is absolute value of u, square root u squared minus a squared. That is the arc secant form. Alright, so look at that one more time. Next one. Integral 1 over a squared plus u squared du is 1 over a arc tan u plus c. So in addition to all the trig integrations that we have done, very important, these three inverse arc sine, arc secant, arc tan forms are vitally important. What you need to do is you need to really learn these by writing them down. Write them down several times so that all these integral becomes part of your general vocabulary. Now we will be using all these in doing the integrations in the next few lessons. Alright. In addition to this, you must also remember some of the basic trigonometric identities. Now the first basic trigonometric identity is this: sine squared x plus cos squared x equal to 1. Now that can also be written as sine squared x equal to 1 minus cos squared x, or cos squared x equal to 1 minus sine squared x. Both these are derived from this Pythagorean identity. The second identity is 1 plus tan squared x equal to secant squared x. Again, that can be written as tan squared x equal to secant squared x minus 1, or secant squared x minus tan squared x equal to 1. Next one, 1 plus cot squared x equal to cosecant squared x. That means cot squared x equal to cosecant squared x minus 1, or cosecant squared x minus cot squared x equal to 1. Now the double angle identities, sine of 2x equal to 2 sine x cos x, and the double angle cosine, cos of 2x is cos squared x minus sine squared x. Actually, there are three forms of it I want you to remember. One is cos 2x is cos squared x minus sine squared x. It's also equal to 2 cos squared x minus 1. Also 1 minus 2 sine squared x. All these three forms are the same for cos 2x. Now all these trigonometric identities and all the integration formulae, once you have identified and learned all, you are now ready for learning some of the integration techniques. And the most important integration techniques is using the known trigonometric formulae to integrate a given function. So you must be very well versed with these forms. So in order to evaluate a given integral, we will use an appropriate substitution to reduce it to one of the standard forms we discussed. All the integration formulae we discussed or we went through now are the standard forms of the integral. So in order to integrate an integral that is not familiar to you, what you need to do is look at what kind of substitution you can do so that you can reduce it to one of the forms of the integration formula that you are familiar with. Alright, let's practice with one integral. Evaluate the integral 2t minus 1 over t squared minus t plus 2 dt. Now, what will you do in a case like this? Well, you need to learn to look critically at the given expression. If you look at the denominator, t squared minus t plus 2. What is the derivative of this? Derivative of t squared is 2t. Minus derivative of t is 1. The derivative of 2 is 0. So the derivative of t squared minus t plus 2 is 2t minus 1. That is the numerator. So what does that tell you? It tells you that you can substitute this quantity to be equal to u. Then 2t minus 1 will become part of the du that you will use to replace dt. That's the way to think about. So what is the incentive that gave me to make the substitution? I'm going to make a substitution t squared minus t plus 2 equal to u. Why did I decide that? Because the derivative of this is actually 2t minus 1. So that when I make this as u, then 2t minus 1 dt can be replaced in terms of u. Alright, let's do that. So we substitute t squared minus t plus 2 equal to u. What is the first thing you do after making a substitution? We take the differential of both sides and obtain du. The differential of t squared is 2t dt. The differential of t is dt and the differential of 2 is 0. So you have 2t dt minus dt equal to du. The differential of u is du. Alright, factor out dt on the left hand side. You got 2t minus 1 times dt equal to du. Now look at that. When t squared minus t plus 2 becomes u, you need to replace this dt in terms of that u. So solve for dt in here. Dt, that's it. No, we have 2t minus 1 dt is what you have on the denominator. And that 2t minus 1 dt equal to du. So, this is now become t squared minus t plus 2 become u, and 2t minus 1 dt becomes your du. So how do you write it? It will be 1 over u times du. There you are. So look at the simple form that the integral has been reduced to. This is the form we can integrate. If you don't remember this, go back and look at the integration formula. What is integral 1 over u du? Integral 1 over u du is ln absolute value of u plus c. And now you can replace our u. Is that right? Replace our u. So the answer is ln absolute value t squared minus t plus 2 plus c. You see, look at the beautiful way we can integrate a complicated quantity like this to make it very simple. And the key is to see what kind of substitution is appropriate. Alright, let's do another one. Evaluate the integral. Integral 2 over quantity 2t minus 1 all squared plus 4 dt. I want you to go back and look at the forms of the integral we discussed and tell me what particular form this is. You need to visualize and see what form is this. Look at this. This is of the form, the denominator is of the form a squared plus x squared, or x squared plus a squared. If this is a and this is x, I can say this is a squared plus x squared. Which integral is that? Integral 1 over a squared plus x squared dx equal to 1 over a arctan x over a plus c. Now look back and learn these forms. So what basic form is this? This is of the form integral 1 over a squared plus u squared du. 1 over a squared plus u squared du is 1 over a arctan u over a plus c. Now, which is your a and which is your u? Your u has to be this that contains the variable, and a is the constant. So, we substitute 2t minus 1 equal to u. That's your u. And once you have your u, you need to replace that dt in terms of that u. So take the differential of both sides. Differential of 2t is 2 dt. Differential of 1 is 0. And differential of u is du. That gives me 2 dt equal to du. Or, there you have 2 dt on the numerator. So we can replace that 2 dt by du. That means this will now become 2 dt is du. Therefore I can write 1 over u squared plus a squared. Our a equal to 2. Is that right? So you need to write this as 2 squared. This will be integral 1 over u squared plus 2 squared du. 2 dt is our du. Alright, what is this equal to? Integral 1 over a squared plus u squared du is 1 over a arctan u over a plus c. So this will be 1 over a, which is 1 over 2, 1 over 2 arctan u over 2 plus c, and replace your u. What's our u? 2t minus 1. So your answer is 1/2 arctan quantity 2t minus 1 over 2, arctan of this plus c. Alright, a beautiful integration. Another one. Evaluate the integral. Integral x square root of 4 minus 2x squared dx. Well, that's a very simple one actually. We have done integrals like this before. Now, what is it that makes it simple? Because if you look at the quantity inside, 4 minus 2x squared, the derivative of this contains x dx. That means you can now replace this quantity by u. You can make a substitution, 4 minus 2x squared equal to u, and then the derivative of this will contain x dx. Therefore, x dx can then be replaced in terms of u. That's right. So let's do that. Since x dx is contained in the derivative of 4 minus 2x squared, I hope you understand what I'm saying. If you find the differential, which is a form of derivative, of 4 minus 2x squared, then x dx is part of that. Is that right? Alright, so we substitute 4 minus 2x squared equal to u. Take the differential of the left hand side. Differential of 4 is 0. Minus differential of 2x squared is 4x dx. And the differential of u is du. So that gives me negative 4x dx equal to du. Now, what we want to do is, after replacing this quantity by u, we need to replace x dx in terms of u. So we solve here for x dx. What is x dx equal to? X dx is negative du over 4. So when this quantity becomes u, x dx will become negative du over 4. So let's rewrite that. 4 minus x squared is replaced by u. Then x dx will become negative du over 4. So the integral now becomes integral square root u times x dx is replaced by negative du over 4. And this negative 1/4 can be taken out. So that means negative 1/4 u to the power of 1/2 du. What is integral of u to the power of 1/2 du? Use the power rule. It will be u to the power of 1/2 plus 1 over 1/2 plus 1. So that is negative 1/4 u to the power of 3 over 2 over 3 over 2. 1/2 plus 1 is 3 over 2. And again, very many times this appears in our simplification. This is 3 divided by 2. That 2 will go up. 2 cancels with the 4, leaving a 2 in the denominator. And 2 times 3 will become 6. So this will be negative 1/6 u to the power of 3 over 2 plus c. Is that right? Okay, so that's negative 1/6 u to the power of 3 over 2 plus c. And there is one more step left. What is that? Replace your u by the original quantity. So that will be negative 1/6 4 minus 2x squared raised to the power of 3 over 2. Well, actually, can we simplify that further? Yes, we can. If you want to factor out a 2 from there, can you factor out a 2 from there? Now, let me show you one more step in simplifying this. Now, 4 minus 2x squared raised to the power of 3 over 2. You see, x to the power of 3 over 2 can be written as x times x to the power of 1/2. You understand that? x times x to the power of 1/2 is x to the power of 3/2. So 4 minus 2x squared raised to the power of 3/2 is 4 minus 2x squared times 4 minus 2x squared to the power of 3/2. I'm going to write that down. Alright, watch below that term. 4 minus 2x squared to the power of 3/2 can be written as 4 minus 2x squared times 4 minus 2x squared to the power of 3/2. Now, 4 minus 2x squared can be written as, we can factor a 2 out. That will be 2 times 2 minus x squared, and 4 minus 2x squared to the power of 1/2 is square root 4 minus 2x squared. So, look at that one more time. I wrote 4 minus 2x squared to the power of 3/2 as 4 minus 2x squared to the power of 1 times 4 minus 2x squared to the power of 1/2. Now, factor out a 2 from there. That gives me 2 times 2 minus x squared, 2 minus x squared times square root 4 minus x squared. Now, I want you to tell me, how does this become this? Now, here I have x squared minus 2. How did that become that? Now, if you remember, if you notice, that 2 is on the numerator for this. That 2 will cancel with the 6, leaving you a 3 on the denominator. And negative, so that's the negative outside. Negative times 2 minus x squared. And if you take that negative inside, it will become negative 2 plus x squared. That's how it becomes x squared minus 2. So, this simplifies to x squared minus 2. In other words, that negative 1, let me write that to the left. There is a negative 1/6 there, and 2 and 3 will cancel, leaving a 3 on the denominator, and the negative, when taken out, it will become x squared minus 2 times square root 4 minus x squared all over 3. That's how that became this. I want you to learn these kind of simplifications. Alright, let me take out my writing from there. Alright, so you have the final result is x squared minus 2 times square root 4 minus x squared over 3 plus c. Another one. Evaluate the integral. Integral 1 over 3x minus 1 minus 1 over 3x plus 1 dx. Actually, this is a simple form we can integrate. We can split this into 2 integrals. So we will do this as 2 separate integrals. That means integral 1 over 3x minus 1 minus 1 over 3x plus 1 dx is integral 1 over 3x minus 1 dx minus integral 1 over 3x plus 1 dx. We will do the integration one after the other. Now, these are simple forms. Why? In the first one, we can make a substitution of 3x minus 1 equal to u to bring it in the form 1 over u du. Alright, so we substitute 3x minus 1 equal to u, but when you do that, we need to replace that dx. So what do? Your dx, you see, it's very simple, you can do that. 3 dx equal to du, is that right? Therefore, dx equal to du over 3. So, when 3x minus 1 becomes u, the dx becomes du over 3. In the same way, in the second integral, we substitute 3x plus 1 equal to v. If the first one we use u, the second one we can use v, just to distinguish. And if 3x plus 1 equal to v, what is dx equal to? If you take the differentials, 3 dx equal to dv or dx equal to dv over 3. That's right. So this will be replaced by u, then this dx becomes du over 3. Then 3x plus 1 will be replaced by v, then this dx will become dv over 3. And so integral 1 over 3x minus 1 dx minus integral 1 over 3x plus 1 dx now becomes integral 1 over u du over 3 minus integral 1 over v dv over 3. And that will now become, we got our substitutions. So we have, this is what we had in the last slide. Integral 1 over u du over 3, I can take out the 1/3. Similarly, I can take out the 1/3 in each. So this will become 1/3 integral 1 over u du minus, take out the 1/3 here, 1/3 integral 1 over v dv. Well, these are familiar integrals. What is integral 1 over u du? It's ln of u plus c, and this one is ln of v plus c. So you have 1/3 ln absolute value of u minus 1/3 ln absolute value of v plus c. We need only one constant, although we have two integrals. Is that right? There's no need to put two constants, because two constants will add to give you a single constant. All right, now if you use the properties of logarithms, what are the properties of logarithms? Ln of x to the power of n is n, isn't it? Ln x to the power of n is n ln x. That means 1/3 ln u is the same as ln of u to the power of 1/3. You remember that property of ln? Ln x to the power of 3 is 3 ln x. Here the number is 1/3. 1/3 ln u is ln u to the power of 1/3. So using that property we can write, first of all, before we do that, let's replace our u and v. Replace your u and v. That gives you 1/3 ln 3x minus 1 minus 1/3 ln 3x plus 1. And now use the properties of logarithm. This 1/3 is actually the power of this 3x minus 1. So that will be ln 3x minus 1 raised to the power of 1/3. Remember, a quantity raised to the power of 1/3 is cube root. So we can write this as ln cube root of 3x minus 1 minus ln cube root of 3x plus 1. How do you combine these using another property of logarithm? Ln a minus ln b is ln a over b. So this will now be ln cube root of 3x minus 1 divided by cube root of 3x plus 1 plus c. You can see we are using a lot of properties of logarithms in here. And this can be written in a single cube root. So our answer will be ln cube root of quantity 3x minus 1 over 3x plus 1 plus c. Although the integrals are simple, watch the simplification, because most of the time it is the algebraic simplification that is where you get lost. All right, another one. Evaluate the integral. Integral 1 over 2 e to the power of x minus 3 dx. Now, this can give you a headache, because if you want to make a substitution 2e to the power of x minus 3 equal to u, and when you take the differential, it will introduce another e to the power of x, but there is no e to the power of x on the numerator. So that is going to really confuse you. So what is the way to deal with it? There is a beautiful way we can make this into a workable form, and that is, you can multiply the numerator and denominator of a quantity like this with the same quantity. So if you multiply numerator and denominator by e to the power of negative x, it will become a beautiful integrable form. So here we have a problem. If we substitute 2e to the power of x minus 3 equal to u, then du will contain an e to the power of x. Try that and see, which is not present on the numerator. If there is an e to the power of x on the numerator, we have no problem. We can make a substitution, this equal to u. But since we don't have an e to the power of x on the numerator, that is a serious problem. So we can change this situation by multiplying the numerator and denominator by e to the power of negative x. Alright, let's do that and see what happens. So multiply the numerator by e to the power of x and the denominator by e to the power of x. If you don't want it, you can just cancel them. But we want them because this is going to change our situation. Alright, tell me now, distribute that e to the power of negative x. You should know that e to the power of x multiplied by e to the power of x, e to the power of negative x times e to the power of x will be 1. Is that right? So the denominator now becomes e to the power of negative x times 2 e to the power of x is 2, and minus 3 times e to the power of negative x is minus 3 e to the power of negative x. So look at the denominator now when you multiply. It will be e to the power of negative x over 2 minus 3 e to the power of negative x. Now we have an e to the power of negative x on the numerator. Therefore, we can now substitute the denominator equal to u, because the e to the power of negative x that is going to come in du can now be accommodated. So we substitute 2 minus 3 e to the power of negative x equal to u. Alright, how do you take the differential? Differential of 2 is 0. And what is the differential of 3 e to the power of negative x? Now, leave that negative 3 alone. The differential of e to the power of negative x is e to the power of negative x times negative 1. So this will be negative 3 times negative 1 will become positive 3 e to the power of negative x dx. That's the differential of the left hand side. So 3 e to the power of negative x dx is the differential of the left hand side. Do that one more time. Check it again. Negative 3 times, find the differential of e to the negative x. It will be e to the negative x times negative 1. That negative 1 times negative 3 gives me positive 3. So positive 3 e to the negative x dx is the differential there, and differential of u is du. So once you have this quantity equal to u, now watch this. E to the negative x dx can now be replaced. E to the negative x dx can be replaced as du over 3. So this is our u, and e to the negative x dx becomes du over 3. So our integral now becomes integral 1 over u du over 3. So that is, this becomes du over 3. And so there is a 1 there, 1 over u du over 3. And we can take out that 1/3. So that will be 1/3 integral 1 over u du. Again, what is integral 1 over u du? Is ln of u plus c. So that's 1/3 ln u plus c. And replace your u. What's our u? 2 minus 3 e to the power of negative x. And as you did before, 1/3 ln of this quantity. What's the role of that 1/3? That 1/3 is actually the power of this quantity. And raised to the power of 1/3 becomes cube root. So that will be ln cube root of 2 minus 3 e to the power of negative x plus c is the result. You can see the way that you've got to see this, what to do there to make it a form which we can integrate is very important. All right, another one. Evaluate the integral. Integral 1 over secant x minus 1. This is again a form that is rather difficult because we cannot really find any integration formula we learned which will fit in here. So what we try to do is try and do some manipulation. We have a secant x minus 1 on the denominator. So why don't we try multiplying the numerator and denominator by secant x plus 1. Why? Because secant x minus 1 times secant x plus 1 is secant squared x minus 1. And secant squared x minus 1 can be simplified using one of the trigonometric identities. Is that right? All right. Now here again, direct substitution is not possible. So we need to do some manipulation. And the manipulation is multiply numerator and denominator by secant x plus 1. So this integral now becomes multiply numerator by secant x plus 1, the denominator by secant x plus 1. What does that become? The denominator becomes secant squared x minus 1. So the numerator is secant x plus 1. The denominator is secant squared x minus 1. What is secant squared x? If you remember our identities, 1 plus tan squared x equal to secant squared x. Therefore, secant squared x minus 1 is tan squared x. So we can replace, recall this, 1 plus tan squared x equal to secant squared x. Therefore, secant squared x minus 1 equal to tan squared x. Let's replace that. So that will be secant x plus 1 over tan squared x dx. That is the quantity for integration. And now the next thing we can try is try and split this into two pieces. You see, this can be written as secant x over tan squared x plus 1 over tan squared x. Is that right? Try that. So split this into two integrals, that are two terms. That would be integral secant x divided by tan squared x plus 1 over tan squared x dx. And then, again, using our knowledge of trigonometric identities, we will replace each of these. What is 1 over tan squared x? 1 over tan squared x is cotangent squared x. All right. We have this is the integral we had earlier, so that will be integral secant x over tan squared x plus cot squared x. 1 over tan squared x is cotangent squared x. And we are now going to replace secant x as 1 over cos x, and tan squared x is sin squared x over cos squared x. So tan x is sin x over cos x. Let's try and replace that. So that will be secant x is 1 over cos x, and tan squared x is sin squared x over cos squared x plus cot squared x. And if you simplify that, what do you get? Well, we know that 1 plus cot squared x equal to cosecant squared x. Is that right? And therefore, cot squared x can be replaced as cot squared x is cosecant squared x minus 1. So let's do that. Replace this as cosecant squared x minus 1. Why? Because cosecant squared x is a form that you can integrate. Cot squared x is a form that you cannot integrate. So replace cot squared x as cosecant squared x minus 1. Well, when you simplify this, will you get this as cos x divided by sine squared x? Now remember, this is 1 over cos x divided by sine squared x over cos squared x. This cos squared x will go all the way to the numerator. And this cos x and 1 cos x will cancel, leaving on the numerator a cos x. So this will simplify as cos x over sine squared x plus cosecant squared x minus 1. Now look at the manipulation that we have to go through to make it in a form that we can integrate. We haven't finished yet. Well, now split this into two different integrals. Now, the left one is integral cos x over sine squared x dx plus integral cosecant squared x minus 1 dx. Now, this is something we can integrate. We know what is integral cosecant squared x is. Do you know? What is the derivative of cot x, cotangent x? Is negative cosecant squared x. Therefore, cosecant squared x can be integrated and minus 1 dx can be integrated. Well, if you look on the left, we can also integrate this by doing a simple substitution. What substitution? We can put sine x equal to u. Then cos x dx will become du. You see how simple it is? So to evaluate the first integral, we substitute sine x equal to u. The sine x become u. Take the differential of both sides. It will be cos x dx equal to du. So when sine x becomes u, cos x dx becomes du. So the first integral will become 1 over u squared du. That's right. And the second integral is a standard integral. We can do that without any substitution. So, with the substitution, the first integral become integral 1 over u squared du, cos x dx is du, plus integral cosecant squared x minus 1 dx. Now all these can be integrated. What is integral of 1 over u squared du? We did this in the last class. Integral 1 over x squared dx is negative 1 over x. Why? Because the derivative of 1 over x with respect to x is negative 1 over x squared. Therefore, integral of 1 over x squared dx is negative 1 over x. Integral 1 over u squared du is negative 1 over u. So that's negative 1 over u. Integral cosecant squared x dx is negative cot x. Because the derivative of cot x is negative cosecant squared x. Integral of cosecant squared dx is negative cot x. Minus integral 1 dx is minus x plus c. So we integrated all these, and what all we need to now do is replace this u with its original quantity. So that will be negative 1 over sine x minus cot x minus x plus c, or negative 1 over sine x is cosecant x. So the result is negative cosecant x minus cot x minus x plus c. So this is the kind of integral you need to spend some time. Now go back and look at this one more time and write this down a couple of times to learn the various steps that we have used in doing this integral. Alright? Okay. Let's do another one. Evaluate the integral. Integral 1 over 4 plus 3x squared dx. What form is this? This is one of the standard forms we had actually seen in the beginning. What form is this? This is of the form 1 over a squared plus u squared, where a squared is 4, u squared is 3x squared. That's right. So let's do that. So this is of the arctan form. Is that right? 1 over a squared plus u squared. Integral 1 over a squared plus u squared du is 1 over a arctan u over a. So we have a squared equal to 4, u squared equal to 3x squared. And we will write it like this. Integral 1 over 2 squared plus, look at that, square root 3x all squared. Now what is square root 3 all squared? Square root 3 squared is 3 times x squared. So when u squared is 3x squared, u is square root 3x. Well, so a equal to 2 and our u equal to square root 3x. Well, if that is the case, what is our dx then? Our dx, when this becomes u, our dx need to be replaced. So our du equal to square root 3 dx. So our dx will become du divided by square root of 3. Okay, so this integral now is integral 1 over 2 squared plus square root 3x is now u squared times dx now became 1 over square root 3 du. Well, this is standard form, and that will be 1 over square root 3, that comes out integral 1 over 2 squared plus u squared du. What is this integral? It will be 1 over a arctan u over a plus c with 1 over square root 3 outside. So that will be 1 over 2 square root 3. How did it become 1 over 2 square root 3? It will be, remember, this will be 1 over 3 times, this integral will be 1 over a. 1 over a is 1 over 2. That's where the 1 over 2 comes from. So this 1 over 3 times 1 over 2 makes it 1 over 2 square root 3 arctan u over a, u over 2 plus c. And that will be replaced by your u. That will be square root 3 over 6 arctan square root 3 over 2x plus c. Alright, so the most important thing here is to see the basic form, a squared plus u squared form, and then make the appropriate substitution. Another one, evaluate the integral. Integral 1 over square root of 2 minus 2x minus x squared dx. Now, this is an excellent candidate to make it of the form square root a squared minus u squared or u squared minus a squared, one of those forms. How? Well, what we can do is we can do some manipulation in the quantity there. This integral can be written in the arc sine form, a squared minus u squared form, by completing the square inside the radical sign. Well, I'm sure you know the skill of completing square. Let's do that. So, what is this equal to? Inside the radical, we're going to complete square. And look at the way I'm going to do that. First, I factored out a negative sign from there, and I wrote under square root 2 minus, after factoring the negative sign, I wrote 2x, x squared plus 2x, x squared plus 2x with the negative sign outside. If you distribute the negative sign, you get that. Now, tell me, what do you add to x squared plus 2x to make it a perfect square? You got the first term, the middle term, and the last term is missing. Remember, for a perfect square, the last term is take half of the coefficient of the middle term and square it. Half of 2 is 1. So add 1 square to this. But remember, when you add a 1 here, you are actually subtracting a 1 because of that negative. You are subtracting a 1 under the radical there. So when you subtract a 1, to compensate that, you need to add a 1. So, look at the way we're going to write it. What will you add to x squared plus 2x to make it a perfect square? Look at the way I have done that. X squared plus 2x plus 1 is a perfect square. That means I have added a 1 inside this bracket. But adding a 1 inside this bracket is the same as subtracting a 1, because everything inside the parenthesis is subtracted. So to compensate for subtracting this 1, I added a 1 outside. So when you distribute this negative sign and simplify, that negative 1 and this plus 1 will go. We haven't really done anything inside. Is that right? Okay, but this 2 added to this 1 will become 3, and this will be x plus 1 raised to the power of 2. This is x plus 1 to the power of 2. Alright, so this will be integral 1 over square root 3 minus x plus 1 squared. Now this is of the form 1 over square root a squared minus u squared, where a is square root of 3, a squared is 3, and u is x plus 1. That's right. So we substitute x plus 1 equal to u. That will give dx equal to du. So x plus 1 becomes u, dx becomes du. Here we have our next form. That will be integral 1 over square root 3 all squared, a squared minus u squared du, and 1 over integral 1 over square root a squared minus u squared is arc sine u over a plus c. So this is the arc sine form. That is integral 1 over square root a squared minus u squared is arc sine u over a plus c, where you are a equal to square root of 3 and u equal to x plus 1. So your answer will be arc sine u over a x plus 1 over square root of 3 plus c. And that's a beautiful integration form, and please go back and have a look at it one more time. Okay, another one. Solve the differential equation dr by dt equal to 1 plus e to the power of t all to the power of 2 over e to the power of t. We have done questions like this before. When you want to solve a differential equation, you can see r is the dependent variable and t is the independent variable. Solving the differential equation means solve for r. So the first thing to do is separate the variable. Multiply both sides by dt so that you have dr alone on the left side. Is that right? Yes. So we need to solve for r as a function of t. The first thing to do is multiply both sides by dt, and that gives you dr equal to 1 plus e to the power of t all squared over e to the power of t dt. And in order to get r, we integrate the left hand side and the right hand side. But before that, let's expand the numerator. What is 1 plus e to the power of t all to the power of 2? A plus b all squared is a squared, that is 1 squared, plus 2ab, 2 times 1 times e to the power of t, there you are, plus b squared, e to the power of t raised to the power of 2. Then you raise a power to the power of 2, simply multiply that power. That will be e to the power of 2t. So e to the power of t raised to the power of 2 is e to the power of 2t, all divided by e to the power of t. Well, now you can split this into 3 pieces. This is 1 over e to the power of t, plus 2 e to the power of t over e to the power of t, plus 2 e to the power of t over e to the power of t. You see, that will, once you write it like that and simplify it, we can integrate each term. What is 1 over e to the power of t? it is e to the power of negative t. And here 2e to the power of t over e to the power of t, e to the power of t will cancel. Alright, tell me, what is this? E to the power of 2t divided by e to the power of t. This needs to be read as e to the power of t. This is something like this, x squared over x will be x. E to the power of 2t divided by e to the power of t is actually e to the power of t. So that will be e to the power of negative t plus e to the power of t dt. We can now integrate each of these. Alright, so we integrate both sides. Integral dr equal to integral e to the power of negative t plus 2 plus e to the power of t dt. Well, what is integral of dr? Is r. And integral e to the power of negative t is negative e to the power of negative t. Integral 2 dt is 2t. And integral e to the power of t is e to the power of t itself plus c. And that is the form of r we have. And this can be rewritten as negative e to the power of negative t is negative 1 over e to the power of t plus 2t plus e to the power of t plus c. Or take e to the power of t common as the common denominator, then e to the power of t will multiply in the last two terms. That would be negative 1 plus 2t e to the power of t plus e to the power of t times e to the power of t is e to the power of 2t. So we take e to the power of t as common denominator and you get this. And therefore, your solution for the differential equation is r of t, r as a function of t, is, write it like this, e to the power of 2t plus 2t e to the power of t minus 1 all over e to the power of t plus c. And this is the best way to write that answer. Alright, let's move on. Evaluate the definite integral. Integral 1 to e 1 minus ln x over x dx. So there is a clue right in there that if you do a substitution, you can do this right away. Why? Because the derivative of ln x is 1 over x dx. You see, so if you can replace 1 minus ln x as u, then its derivative will contain 1 over x dx. And that is the clue that you should see right away. Now think of a substitution that will reduce this to a standard form. It's a very simple 1 minus ln x equal to u. Why? Because the derivative of ln x contains 1 over x. That's right. So we say 1 minus ln x equal to u. The differential of 1 is 0. The differential of, with the negative, differential of ln x is 1 over x dx. Differential of u is du. So 1 over negative 1 over x dx equal to du, and therefore 1 over x dx. See, when this becomes u, you need to replace 1 over x dx. 1 over x dx is negative du. Let's do that. Well, before we do that, we need to replace our limits using this substitution. Alright? Now here, when x equal to 1, let's bring x equal to 1 here. What is ln 1? ln 1 is 0. So when x equal to 1, u equal to 1. So that limit will remain the same. When x equal to e, what is ln of e? ln of e is 1. So ln e is 1. 1 minus 1 is 0. So when x equal to e, u equal to 0. There you are. So your limit will become, in place of 1 to e, it will become 1 to 0. So integral 1 to e 1 minus ln x over x dx now becomes integral 1 to 0, integral 1 to 0, this is our u, and 1 over x dx is negative du. And take the negative sign outside, it is integral 1 to 0 u du, and integral of u du is u squared over 2. Is that right? That's right. So that would be negative u squared over 2 from 1 to 0. The upper limit is 0, so put the upper limit minus the lower limit. That will be upper limit u equal to 0 gives me that quantity 0 minus the lower limit u equal to 1 makes that 1 squared over 2 is 1/2. That would be minus 0 minus 1/2 equal to 1/2 is the value of that integral. Well, this has been a good one too.